Let's take a look at how to write piecewise functions from context problems, from words. All right, so you're writing an equation Dr. Phi based on the length time. Up to 6 minutes costs $50. So what does that mean? That means you can't have negative minutes, so we're going to start at 0. And up to including 6. So x is between 0 and 6 inclusive. And that's going to be 50 bucks. All right, over 6 and up to 15. So we need greater than 6, but up to and including 15. So that's going to be including 15 from 6. So x is between 6 and 15, including 15. And then over 15, strictly over. Now you can't have both of them equal to, because then it'll overlap. So it's going to be $80 plus 5 per minute. So $80 plus 5x, because 5 per minute. All right, and that's your function. All right, let's take a look at a more complicated one. So it's 20 a day for the first week. After that, the cost decreases 17. Write a piecewise function. All right, so the first one is $20 every day. So $20 times x, because it's $20 per day. Now this has week and day, so we're going to make it all week. So for the first 7 days, 0 to 7, because again, you can't have negative time, inclusive. And then it decreases to $17. So when you're writing the second equation, you have to take into account the first equation. So for the first 7 days, is $20. So you write that down, $20 times 7, the first 7 days. Then it goes down to 17. So I'm going to say plus, and then it's going to be $17 for how many days? It's the day after the 7th day. So how are we going to represent that? We're going to say take whatever day you want, like 20, minus the 7 days you've already accounted for in that 20 times 7. So it'll be x minus 7. All right, so that's very, very important. So you start off with what it is, then take away what you've already counted so that you double count. And that's going to give you 140 plus, go ahead and distribute to 17x, and then 17 times negative 7, which is negative 119. So your second equation is 17x plus 21. And the restriction is any day that's bigger, strictly bigger than 7, because they can't overlap. So let's go ahead and prove it in such a way that you guys would probably have calculated it in the first place. So let's have a table. Let's label it x days and dollars in y. So if 1 day, how much would that cost? $20. 2 days, 20 times 2 because it's 2 days, $40. 3 days, 20 times 3 because it's 3 days, 20 times 4 for 4 days, and so forth, right? All the way to the 7th day. So we're going to just keep making this table until the 7th day so I can prove that this equation will work. Now, when you get to the 7th day, the price changes from $20 to $17. But in order to get this 8th day, I have to calculate the 140, the price for that 7th day, plus an additional 17. Now, I am going to put times 1 day, 17 times 1 day over 7 days, right, which is 157. So the 9th day is going to be the 140 for the 7 days, plus now 17 times, how many days has it been at $17? 2 days. And that's going to give me 174. And that's when the equation changes. So let's compare what we have. So we have 20 times 7, which is the 7th day. And then we have 17x minus 7. Remember, x minus 7. So on the 9th day, for example, 9 minus 7 is 2. And that's where I get that 2 from. So this equation works. Now that I know this equation, what's the cost to park 10 days? Well, that means x is equal to 10. So plug 10 into which one? The one that's greater than 7. So that's going to be 17 times 10 plus 21, which is going to give me 191. All right, let's double check that. So it's 10 days. We already have a table for 9 days. So all we got to do is add 174 plus 17, which gives us 191. All right, so now Miss Anderson goes on 2 trips. On the first one, she parks for 5 days. On the second one, she does for 8. What's the difference in the cost? All right, so when x is equal to 5, which equation do I look at? Between 0 and 7. So that's 20 times x, which is 5. When x is equal to 8, which one do I look like? Bigger than 7, right? So 17 times 8 plus 21, which is 157. Now the question is, what's the difference between those two? So 157 minus 100, which is equal to 57. Let's take a look at one more example, and then you guys are going to do one just very similar to this. So a baker has the following pricing. The first 100 cupcakes, and listen, just highlight, underline something, is $2. The next one's 150 is 175, and the excess of 250 is 125. Let's write that down. So $2, right? If x is between what? 1 cupcake to 100 inclusive. So I'm going to go ahead and put the equal signs underneath the inequalities. Then for the next 150, it's 175. So 150, that's 250. So from 100, not inclusive because it doesn't include 100, to inclusive 250, it's $1.75. And anything bigger than 250, not including, is $1.25. All right, let's write that down mathematically. So the first one's pretty easy. So it's just 2x because 2 times the number of cupcakes you have, up to 100 cupcakes. So put in the domain, which is on the bottom. The second one, we're just going to put in the domain first. And the third one, we're going to put in the domain. And we're just going to come and calculate these two equations. So this $1.75 has included 100 cupcakes. So that's going to be 2 times for this next interval, 2 times the 100 cupcakes plus $1.75 times x minus what I've already included, which is 100 cupcakes. All right, so working that out, that's going to be 200 plus, and then distribute that 1.75x minus 175. Okay, go ahead and simplify that. 200 minus 175 is 25. So this is 1.75 plus 25. All right, now to get into the third interval, we already have the first two interval, and the second one includes the first one. So we're going to start with the second equation, 1.7x plus 25, and just replacing the x with what? 250, because there's the number of cupcakes I have in that interval. I forget to write 25 here, so write plus 25. Then we're going to add on $1.25 for every cupcake greater than 250. So we have to say x minus 250 because we've already counted the 250. So evaluating that in a calculator, 1.75 times 250 is 437.50 cents plus the 25. Then distributing the $1.25 into the parentheses, 1.25x, and then 1.25 times negative 250 is negative 312.5. Then combine all the numbers together. You're going to get 1.25x, because it's the only one with the x. And then for all the numbers, you're going to get 150. So plus 150. So that's the equation. 1.25x plus 150. That's what you write in there. So now you have your equations. You can evaluate 15 dozen cupcakes. And what does a dozen mean? Times 12. So it's 15 times 12, which is equal to 180. So which equation would I need for 180? The one in the middle. So 1.75x, which now is 180, plus 25. Put in all that in a calculator. You get $340. And last question, if a couple orders 450, where do I get, which equation do I use? The last one, 1.25 times 450 plus 150, which is going to give me $712.50. So that's how you write piecewise functions from words or from context problems. Let's practice.